Hello viewers, very good afternoon. Myself Muniraju Naidu, Assistant Professor, Department of Computer Science and Engineering, Institute of Aeronautical Engineering, Hyderabad. So in the previous classes, already we discussed about introduction about computer networks and OSI reference model and TCP/IP protocol suite. So today we are going to discuss about transmission media. Transmission media. So we know what is meant by a transmission media. Particularly, whenever we deal about a data communication subject or data communication terminology, this transmission media plays a vital role because the transmission media is a physical path which exists between the transmitter as well as the receiver. So we know how it is related to the computer networks. So whatever the network, various nodes must be communicated through some media. That particular media may be either guided media or unguided media. Simply say that either in wired communication or wireless communication. So that means the transmission media is a channel through which the data is sent from one place to another place. One place to another place. So that's why the transmission media plays a major role in computer networks. So today, this is the overview regarding the transmission media. We know the transmission media is classified into two categories. One is guided media, second one is unguided media. So guided means wide communication, unguided means wireless. So nowadays we may use space or satellites. Then what are the various characteristics and quality determined by medium as well as the signal? And which one is important for guided media? You know, the medium is more important for guided media, whereas for unguided media, the bandwidth produced by antenna is more important. So the key concerns, that is the basic parameters here we need to consider, that is data rate as well as the distance. Because if you take either guided media or unguided media, these two are important terms. What is the data rate, right? And how much distance it transmits. See, what are the various design factors regarding this particular transmission media? You know, bandwidth, transmission impairments, interference, number of receivers. These are the basic design factors of any type of transmission media. See, first of all, what is meant by guided media? So before going to these design factors, you know some basic terminology. So what is guided media? Generally, guided media, which is also called as a wide media or bounded transmission media. Bounded transmission media. Why here we can call it as a bounded transmission media? See, in case of wide or bounded transmission media, various signals, those are transmitted, which are directed and confined in a narrow pathway by using the physical links. So wide media, that is guided media. Here the signals are being transmitted which are directed and confined in a narrow pathway by using various physical links. So that's why the basic features of these guided media are high speed and secure. High speed as well as the secure. So what are the various categories of guided media? What are the categories of various unguided media? So we know the basic guided media that is we are using from the earlier days, that is a twisted pair and coaxial cables and optical fibers. Right? We will discuss later. So coming to the design factors, the bandwidth, transmission impairments, interference, number of receivers. Based upon this number of receivers, whenever we will apply to any multi-point networks, there we need to introduce more attenuation, because more receivers introduce more attenuation. See, these are the categories of guided media, that is guided transmission media, twisted pair, coaxial cables and optical fibers. See, what is the various transmission characteristics of guided media? Transmission characteristics of guided media. See, first one is frequency range, then attenuation, then delay, then repeater spacing. Among these, the twisted pairs with loading, this is the first category. Second one, twisted pairs, that is a multi-pair cables, coaxial cables, optical fibers. For twisted pairs, that is a basic thing. The frequency range is 0 to 3.5 kilohertz. Whereas the typical attenuation is 0.2 decibels per kilometer. Similarly, typical delay 50 and repeater spacing 2 kilometers. See, while we observe these transmission characteristics, from the basic twisted pair to the optical fibers, see here the spacing is increased. The spacing is increased. Is it right? So, depends upon our application whether we may use twisted pairs, coaxial cables as well as the optical fibers. So these are the basic transmission characteristics of guided media. So what is meant by twisted pair? What are the characteristics of this twisted pair? So we know twist, just like this, twist. So what happens? You normally observe these twisted pairs in any electrical cables, right? So these are basically separately insulated, that is multiple cables twisted together. Those are often bundled into the cables. Usually we may see these twisted pairs in any construction point of view. Right? If you take any apartments or buildings or colleges. So more number of twisted pairs which carries the information. Because these are separately insulated and twisted together. Then the data is transmitted through these twisted pair. That's why here we can call as a twisted pair. So what are the various applications of these twisted pairs? From the earlier days to nowadays, we may use these twisted pairs for certain applications, because that is the most common medium. Another one is a telephone network. So where we can use, that is we can simply call as a in subscriber loop between the house as well as the local exchange. So we know that is a traditional, we may use landline phones. Some of you may use landline phones, right? So whatever the phone we are having in our house, that particular phone is communicated with these twisted pairs with the local exchange, with local exchange. So this particular local exchange is communicated with some other phones also. Then within the buildings, we can simply call as a PBX, private branch exchange. And most of the applications may use these twisted pairs like LAN for LAN cables, which may range from 10 Mbps to 100 Mbps. So these are the basic twisted pair applications. And what are the pros and cons of twisted pair? This is the cheaper when compared to the optical fibers as well as the coaxial cables, because this is the only technique we may use at the earlier days. Then easy to work with twisted pairs, but the drawback is a low data rate. That is, when compared to nowadays wireless as well as optical fibers, twisted pairs is having very low data rate, and the data may be transmitted for within the short range. That means whatever the applications we are implementing for exchanging the data between very short range, there we can use these twisted pair cables. Then what are the various transmission characteristics of these twisted pairs? See, already we know some basic overview of transmission characteristics of transmission media. Similarly, the twisted pair is also having analog, digital, and there is a limited distance. That is the drawback existing in the twisted pairs. Limited bandwidth, limited data rate. So analog means here the amplifiers we need to keep for every 5 to 6 kilometers, because the twisted pairs carries the information between very short range distances. For digital purpose, use either analog or digital signals, but here we need to keep repeaters for every 2 to 3 kilometers. And then the bandwidth is 1 megahertz and the data rate is 100 megahertz. These are the basic transmission characteristics of twisted pairs. Then, according to this, the near transmitted signal is picked up by a near receiving pair. So then only we need to transmit data between any pair of nodes. So this is the twisted pair 1. This is the twisted pair 2. So for example, this is the source, this is the destination. So there is no direct communication between source to destination. So now we can use this node, which is acts as a intermediate node. So what happens here? The coupling of signal from one pair to another pair. So that's why in case of twisted pairs, the coupling takes place whenever the transmit signal entering the link couples back to the receiving pair. So we may move to the next categories. Those are, this transmission media, maybe that is UTPs or STPs. So according to the transmission media, whatever the twisted pairs we are using, those twisted pairs are categorized into UTPs as well as STPs, unshielded twisted pair as well as the shielded twisted pair. There is a very basic difference between unshielded as well as the shielded. Very earlier days, these unshielded twisted pair may use, that is, for example, if we take the ordinary telephone wire, so that's why this is the cheapest and which is easy to install. The drawback is which suffers from external EM interference, electromagnetic interference. So to overcome these drawbacks, then we may introduce these shielded twisted pairs. Shielded twisted pairs. These are metal braid or sheathing that reduces the interference. That means when we can go for the next technique or next version, means whatever the drawback existing in the previous one, to overcome that particular drawback, here we may choose the new one. What is the drawback existing in the unshielded twisted pairs? Which suffers from external electromagnetic interference. So in case of shielded twisted pair, the design of shielded twisted pair which reduces the interference. So automatically it is more expensive when compared to the unshielded twisted pair. And these twisted pairs, regarding the shielded twisted pairs, those are very hard to handle because they are very heavy. So what are the various unshielded twisted pairs categories? See, there are a number of categories: category 3, category 4, category 5, category 6, as well as the category 7. There is a slight difference between these categories of unshielded twisted pairs. The category 3 of any unshielded twisted pair which carries information up to the 16 megahertz, and the twist length is 7.5 centimeters to 10 centimeters. Similarly, category 4, which carries information up to 20 megahertz, whereas category 5, 100 megahertz. So that's why most of the offices or apartments, they are using this category 5 unshielded twisted pair. So here the twist length is 0.6 centimeters to 0.85. See, there is a lot of difference. Observe here. Category 5, the twist length is 0.6 centimeters to 0.85. Whereas the twist length of category 3 is 7.5 to 10 centimeters. So there is a lot of difference between these categories. We will discuss in this table. Comparison of shielded as well as the unshielded twisted pair. See, there are categories we have, but mainly concentrates on category 3 as well as the category 5. There is a lot of difference. See, for example, here we need to consider the parameters, attenuation as well as the near end crosstalk. For example, the frequency is 1 megahertz, then the category 3, the attenuation, that is in the form of decibels per 100 meters, that is 2.6, whereas the category 5, 2.0. Similarly, whenever the frequency is increased from 1 megahertz to the 4 megahertz, the category 3 attenuation is 5.6 decibels, whereas the category 5 is 4.1. That means whenever the frequency range is increased, then the category 3 attenuation is somewhat increased while compared to the category 5. See here, this is 2.6, this is 2.0, this is less. This is 5.6, this is 4.1, this is more, this is less. This is 13.1, this is more, this is less. Similarly, near end crosstalk. See here, 41, 62, 32, 53, 23, 44. So this is reverse. This is reverse. According to the category 3, this is decreased. right? So in this way, we need to compare both shielded as well as the unshielded twisted pairs. Particularly here, we need to categorize, concentrate on categories like category 3 as well as the category 5. Then coming to the next parameter, that is the bandwidth. The bandwidth, cable type, link cost. So whatever the categories we are having, basic categories like category 3, category 5, category 6, category 7. These are mentioned like category 3, that is class C, category 5 class D, 5E, 6 class E, category 7 class F. See here, the bandwidth is increased to each and every category. So that is the basic principle, right? So nowadays, whenever you can go for the updated versions, definitely you can get some high range. Cable type. See here, in case of category 3, class 3, we have UTP, and category 5, class D, UTP or FTP. Similarly, 5E, UTP or FTP. Category 6E, UTP or FTP. But category 7, that is SSTP. So what is the link cost? Link cost. See, that is range is increased from 0.7 to 2.2. 0.7 to 2.2. Twisted pair categories as well as the classes. So that deals about the twisted pairs. Then second category, in case of transmission media, that is guided transmission media, coaxial cables. I know you are very familiar about these coaxial cables because we learned this particular concept in physics, intermediate physics, right? Coaxial cables. See, the coaxial cable, the structure of coaxial cable looks like this. Here, initially we have, this is the outer sheath, this is the outer conductor, and there is a inner conductor. These are insulation. So outer conductor is braided shield, whereas the inner conductor is solid metal. These two are separated by some insulating material. Insulating material. So this is the coaxial cable, basic coaxial cable. So which looks like this. Outer sheath, outer conductor and inner conductor. These two are separated by some insulating material. What are the various applications of coaxial cable? So this is the most versatile medium for data transmission purpose when compared to these categories like twisted pair categories. So where we can use these coaxial cables? Television distribution, cable TV. So we already seen that cable TV we can call as a dish wire. So which carries information over a longer distances when compared to the twisted pairs. Twisted pairs transmits the data between shorter range, shorter distances. When compared to the twisted pairs, the coaxial cables transmits distance for a longer distance. So generally, landline telephones, those are communicated with local offices, trunk offices, head offices with these coaxial cables. So longer distance telephone transmission which carries around 10,000 voice calls simultaneously. So that's why these coaxial cables are being replaced by fiber optics. So that means there are some gaps between twisted pairs, coaxial cables as well as the optical fibers, fiber optics. Another application is short distance computer system links as well as the local area networks. Local area networks, local area networks, how the systems are communicated with the local area networks. Then what are the various transmission characteristics of these coaxial cable? Here, coaxial cables transmits the information somewhat larger distances when compared to the previous technique, that is the twisted pairs. So analog means here the amplifiers are inserted for every few kilometers, and which is closer if the frequency is increased, that is it carries the information up to the 500 megahertz. And whenever we may implement these to any digital applications, here we need to keep the repeaters for every 1 kilometer, because which is closer for higher data rates when compared to the previous techniques. Then third one, optical fibers. Optical fibers. See, another point of these optical fibers, particularly whenever we need to transmit some data in a secure fashion. Secure in the sense these are wide communications. There is no scalability of twisted pairs as well as the coaxial cables when compared to the optical fibers. There is a lot of damages generally happens due to atmospheric conditions or weather conditions. So the optical fiber cable, which looks like this, see here, which is made up of either glass or plastic core. Here, the laser, or we can call it as a LEDs, a light emitting diodes, which is a specially designed jacket. See, this is the structure of optical fiber. Here, two parameters mainly we need to concentrate: angle of incidence as well as the angle of reflection. So the optical cable fiber looks like this, but the data is transmitted through laser or LEDs. So whenever the light at less than some critical angle which is observed in the jacket, see as shown in the diagram. So whatever the data which carries through these optical fibers. So these optical fibers which increases the data speed as well as the distance when compared to the twisted pairs as well as the coaxial cables. What is the major advantage of these optical fibers? First of all, we need to carry huge amount of information between number of nodes. Then these optical fibers which uses the lower attenuation when compared to the twisted pairs as well as the coaxial cables. See, there is a greater capacity, that is the data rates of hundreds of Gbps. From the previous techniques, the data rate is very less, that is according to the Mbps. Whereas the optical fiber cables can transmit data in terms of Gbps. And smaller size as well as the weight. Smaller size and smaller weight. And lower attenuation. This is electromagnetic isolation. And the important one is this is a greater repeater spacing. Greater repeater spacing. So these optical fibers applications which includes, see, trunks, long haul trunks, metropolitan trunks, rural exchange trunks, subscriber loops as well as the LANs. There are a number of applications. These applications which carries information to a longer distances. Whatever the application which carries information to longer distances, there we can use these optical fiber cables. What are the various transmission characteristics of these optical fibers? See, the optical fiber cables which acts as a waveguide for up to 10 power 14 to 10 power 15 hertz, because the various portions of infrared as well as the visible spectrum is there to carry the information. So why it is cheaper and why it transmits large amounts of data within a short period of time? Here we use these LEDs as well as the ILDs, that is injection laser diode, and which works on the principle that is wavelength division multiplexing rather than frequency division multiplexing. It works on the principle wavelength division multiplexing. So we know LEDs are cheaper, wider operating temperature range, and those are last longer. So many days you may use that particular LEDs. And ILDs, those are injection laser diode. These are more efficient as well as which transmits data at a high rate within the specified time. So these are the various characteristics of optical fibers: LEDs, ILDs and WDMs, wavelength division multiplexing. See here, these are the various modes of optical fibers. We may call it as a transmission modes of optical fibers. First one is a step index multimode. Second one is graded index multimode. Third one is single mode. Step index, graded index as well as the single mode. See here this particular diagram which observes that this is the optical fibers. We know these particular optical fibers which carries the concept that is a reflection of light through a core. Reflection of light through a core which is made up of either a glass or a plastic. Because here the core is surrounded by a lens dense glass. The core is surrounded by a lens dense glass or plastic covering which is called as a cladding. What is meant by cladding? What is the purpose of cladding? Which is used for transmission of large volumes of data. Large volumes of data. Because whatever the cables we are using, there are a number of categories of optical fiber cables. These cables may be either unidirectional or bidirectional. Because which uses WDM, wavelength division multiplexing. We know wavelength division multiplexing which supports two modes, that is unidirectional as well as the bidirectional mode. Sir, what is the importance of WDM? Why we may use this WDM? There are a number of advantages. First one is we may increase the capacity as well as the bandwidth. Second one, that is the lightweight. Third one, which uses the less signal attenuation and which is resistance to corrosive materials. Resistance to corrosive materials. Right? So, these are the various modes: step index multimode, graded index multimode and single mode. Single mode. Right? See the difference here. Here the input pulse looks like this. See, which transmits information like this. The output pulse looks like this. So step index, step by step, graded index, and single mode. Single mode. Then frequency utilization for fiber applications. Frequency utilization for fiber applications. See, wavelength range is 820 to 900 nanometers. There the frequency range is around 366 to 333. Fiber type is here, we may use a multi-mode. Whereas the wavelength is increased from 900 to 1280 to 1350, then the fiber type is a single mode. Right? So, whenever the wavelength is increased, see here, there is a slight variation in frequency also. The frequency is decreased and the applications are also varies, right? So the basic one is 820 to 900 means the application is LAN. Then we may increased around 1620s, there we can use wavelength division multiplexing. This is frequency utilization for fiber applications. So this is the last one, that is a wireless transmission frequencies. Wireless transmission frequencies. 2 gigahertz to 40 gigahertz, that is a microwave, highly directional point-to-point satellite. Whenever the wireless transmission frequencies are from 300 megahertz to 1 gigahertz, that is a omnidirectional as well as the broadcast radio. And third one, 3 into 10 power 11 to 2 into 10 power 14, infrared as well as the local. Infrared as well as the local. Right? See, radio waves. Radio waves. These are very easy to generate and penetrate through buildings. Right? So what happens? According to the nodes, the sending as well as the receiving antennas need not be aligned because here the radio waves are penetrate through the buildings. So the frequency range here for radio waves 3 kilohertz to 1 gigahertz. Right? So generally, FM radios and cordless phones which are used this particular technique, that is the radio waves. Then second one is microwaves. Microwaves. So what happens in case of microwaves? We can call as a LOS property, right? A line of sight. LOS means line of sight transmission. That is the sending as well as the receiving antennas need to be properly aligned with each other, because here this one microwaves may use the line of sight property. So the distance covered by the signal which is directly proportional to the height of that particular antenna. Right? So that means here the frequency range is for microwaves 1 gigahertz to 300 gigahertz. So where we can use this particular microwave technology, particularly for telephone communication as well as the mobile communication. Mobile communication as well as the telephone, or we can call as a TVs, that is a television distribution. Then third one is infrared. Infrared. Basically infrared is particularly used for very shorter range distances. Very shorter range distances. But the drawback is these infrared waves doesn't penetrate any obstacles, just like our radio waves as well as the microwaves. So the frequency range is here 300 gigahertz to 400 terahertz. So these infrared basically we used nowadays in TV remotes and wireless keyboard and wireless. See, this is the wireless pen, wireless mouse, printer, etc. So there are number of wireless transmission media nowadays we are using, right? So that's about today's concept. So today we discussed about transmission media. What is transmission media? What is the purpose of transmission media? Why we studied this transmission media, and what are the various categories of transmission media? Guided media as well as the unguided media. Right? In case of guided media, what are the various categories? Like twisted pairs, coaxial cables, fiber optics. Similarly, unguided media, space, satellites, that is a wireless. So twisted pairs, what is twisted pair? What are the various categories of twisted pair? What is the benefit of twisted pair? And what are the applications of twisted pairs? Similarly, coaxial cables. What is the advantage of coaxial cables when compared to the twisted pairs? What is the range of coaxial cables? And what are the benefits of coaxial cables? Pros and cons of coaxial cables. Then when compared these two, the third category, that is the optical fibers, fiber optics. What is the advantage? What is the range? What are the various transmission characteristics of these transmission media? And lastly, wireless transmission characteristics. So that's about transmission media. So we will see in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.